Hey Pre-Calculus, Mr. Rashid here, and we are looking today at graphing circles and finding their center and radius. Now, circles are something you probably looked at in geometry a long time ago, and there's a lot of terms with circles like secant, chord, and all that stuff, but here are the terms that you'll need to know for this particular section. So the first thing is a circle represents all the points that are the same distance away from some center. So the center of a circle, let's say it's right there, and all of these points that are on the edge of this circle, they're all the same distance away. And that distance is called the radius. So the radius is drawn here to this particular point. But any one of these points could be a radius, right? And typically you use a letter R to represent the radius. So this could be R, this could be R. So any of these could be the radius of that circle there. Then the other set of terminology you may need is diameter. And with diameter then, it's a line that goes from one point on the circle to another point on the circle, but it has to go through the center. So that is called a diameter. And so you can see here one side of the diameter is one radius and the other side is another radius. So the diameter is twice the radius. Then the last term we'll need is tangent. And a tangent just touches the circle at one point. It touches that circle at that one point, and that's a straight line that extends out. Okay, so that's called a tangent. The interesting thing about a tangent is that it's perpendicular to the radius. So that's a 90-degree angle with the radius at the point that it touches that circle. Okay, so with that terminology out of the way, we're going to look at the equation of a circle in standard form. So the equation of a circle in standard form looks like this. It's x minus h quantity squared plus y minus k quantity squared is equal to r squared. And so from this equation of a circle in standard form, we can find its center. The center would be hk, and we can also find its radius. The radius is r. So let's look at an example where we use this equation. So we've got to graph this equation here. So let's look at where the center and the radius are first. So for the center then, we're going to take the opposite of the number that's next to the x, the quantity squared, and that is 1. We're going to take the opposite of the number that's next to the quantity y squared, and that is negative 5. Opposite of 5 is negative 5. So that represents the center of our circle. Then you'll see here it says r squared. So that means we have to take the square root of this number to represent the radius. So the radius is going to be the square root of 9 or is equal to 3. You can also write this as equal to 3 squared, and then it looks a bit more like that equation that we saw on the top. Okay, so in order to graph these things, what we do is we start at the center here. So this is 1, negative 5. So this is 1 here and negative 5. So that is my center. Okay. And then take this radius and go in equal directions to the north, south, east, and west, and there you get your circle. So we're going to go 3 up from the center, is right there. We're going to go 3 down, and I'm going to go 3 to the right, and then 3 to the left, and that's it. So, and then just do your best at graphing a circle through those points here. And that's it. That's our graph for the circle. Okay, so let's do some different kinds of examples. So here we're not given the equation. We're given the center and the radius, so we can graph it, of course, right away, but let's write the equation also for this one. So x, and we're going to have the quantity squared plus y, and we're going to have this quantity squared equals r squared, and in this case it's the radius squared, so that's going to be 5 squared. And then the quantity next to the x is going to be the opposite of the x value of my center, so that's going to be minus 3. And the quantity next to the y is going to be the opposite of this, which is positive 2. So this y plus 2, you're maybe thinking, well, how does that look like that? Well, it's just y minus negative 2, right? And y minus negative 2, then it's y plus 2. Okay, now that we've written the equation, let's graph this. So our center is at 3, negative 2. Okay, so that is my center. Then let's, we've got our radius of 5, so we're going to go 5 up, 5 down. You can do these in any order. You don't have to start with these ones. And then 5 to the right, and 5 to the left. Okay, and I'm going to draw my circle the best I can through this. There we go. This is a little bit off, but that's try your best, and that's good enough here for this section. Okay, so let's do one more example then. So write the equation of the following circles and graph them. Okay, so the center is at negative 2, 1, so we want x and whatever quantity that is squared plus y, and then quantity squared, and is equal to r squared. Now we don't really we're not given a radius here, so let's look at this graphically first, and then we'll come back to writing that equation. So the center is at negative 2, 1, so negative 2 on the x, and then 1, so that is my center right there. Now we're told that it's tangent to the y-axis, so the y-axis is over here. And remember what I said, if about tangents, if a circle is tangent, I can draw a radius to the tangent, and that's going to form a perpendicular line to the tangent. So the radius of the circle looks like it's 2 units away from the center, because it's just going to touch that tangent and at that point, and then that's the only point that's going to be on that line that's going to be on the circle as well. So the radius then is 2, and that's squared, right? Remember the form is radius squared for our circle. And let's use our center now for our x, so this is x plus 2 squared, and for the y it's y minus. Remember, we're doing opposites for those. So now we've got the equation, we've also got the radius, so we're good to go. We use the same radius to go up here too from the center, to the left here too, and down too. And then that is my circle. Okay, let's look at now some other examples. So we may be given circles that are in a more general form that kind of looks like this. It looks like a whole bunch of terms that are all scrambled. Now, when we look at parabolas and ellipses and hyperbolas, we'll get a better sense of how to tell which kind of equation is what kind, but now we're just starting at circles. So the main thing I would look for with circles is make sure that your coefficients are the same for your x squared and y squared terms. If your coefficients are the same for the x squared and y squared terms, then that is a circle. If it's not, then it's going to be something else. And if there's a negative coefficient for any of those, then it might also be something else. Okay, so now what I would do with this is, what I want to do is make it look like, remember this x minus h squared plus y minus k squared is equal to r squared. So I want to make this whole thing look like that. So what I would do here is separate all the x terms out. So I've got x squared plus 6x, and then here's my y squared terms, y squared minus 8y, and then move this this number to the other side. So I would subtract 18, because I need some kind of number there to form my radius. So subtracting 18, then I get this whole thing is equal to negative 18. Right, so all I did was I subtracted 18 and subtracted 18 from both sides. Now, we've got to make it look like this and look like this. The only way to do that is completing the square. So to complete this square, then, we need to add something here to this. And what I would add then is something to complete the square. So we take half of this and square it. So half of that is 3, and to square it, that's plus 9. Now I added 9 to this side of the equation, so I've got to add 9 to the other side as well. Okay, now let's complete the square with the y's. So half of negative 8 is negative 4, and squaring that is 16. So this is 16. And remember, I added 16 there, so now I've got to add 16 to the other side. Okay, so let's factor these now. This is x plus 3 squared, and over here I've got y minus 4 squared. And let's do the math on this. 9 and 16 is 25, and that is 7. Now remember, I need to get a radius out of that, so that's going to be some quantity squared. So this is x plus 3 squared plus y minus 4 squared is equal to the square root of 7 squared. Right, so in that case, it is it's not a perfect integer. Okay, so now we have we can go ahead and graph this thing. So the center is at the opposite there is negative 3, and the opposite of the y's is positive 4, and then the radius is the square root of 7. And we can probably just make an estimate of this. So square root of 7, let me plug that into my calculator here. So 7 so I get 2.65. So probably 2.5-ish, I can make an estimate. Let's find the center first. So the center is at negative 3, 4. So negative 3 and then 4 up. That's the center. And then I'm going to go 2.5 sort of up and down here. So that's there. And then to the right. And then to the left. Okay, and then that is my circle for this. Okay, so that's a great example of how we would take something that has got a whole bunch of terms. First of all, identifying that it's a circle, then using completing the square to identify then the center and the radius, and then graphing it. Okay, so let's do one more example here. Okay, so this is the last example for today. So we're graphing the following circle. So similar problem like the last one that we did, where there's a whole bunch of terms given to us and we have to get it into that standard form so we can identify that the center and the radius. Remember, for these circles, the coefficients in front of the x and the y squared, x squared and the y squared, they have to be the same. And at this point, I noticed that I can divide everything here by 2. I can divide the whole equation by 2. So I end up here with x squared plus y squared minus 10x plus 4y plus 17 equals 0. So now, just like we did, we want to get it into this kind of form, x minus h squared plus y minus k squared plus r squared. So let's separate out everything with an x squared. So x squared minus 10x. Okay, so that's going to be my x, everything that I see with an x. And then let's look at everything with the y. So y squared plus 4y. And then let's move that number to the other side. So let's just subtract 17. And so this is all equal to 17. So what I need to do now is complete the square. So what do I add to this and what do I add to this? So we take half of negative 10, and that's negative 5, and we square it. So this is going to be plus negative 5 squared. And over here, this is going to be half of 4 is 2, and that's 2 squared. Okay. So let's finish this off then. So this is x minus 5 squared. And here I have y plus 2 squared. So that's the factored form. And oops, I forgot. So over here, we added 25 and we added 4. So I've got to add those to the other side of this equation too. So I add 25 and I add 4. So whatever I added to this side, I had to add to the other side. So notice this was negative 17. So negative 17 then plus 25 plus 4, so that's 29 minus 17, so I get 12 out of that. So this is equal to 12. I want to write that as some kind of radius squared. So this is x minus 5 squared plus y plus 2 squared is equal to the square root of 12 squared. And now that looks like this expression up here. This should be an equals. Now that looks like that expression up there. Okay, so let's finish this off. We have a center then. The center is at 5. That's the opposite of this thing. And then negative 2. And then my radius is the square root of 12. Let's put that in our calculator. And that is 3.5-ish. So approximately 3.5. So let's find our center. So we're at 5, negative 2. So that is my center. And I'm going to go 3.5 just in every direction here. So that's 3.5-ish. And that's 3.5 there. And then this is 3.5. Then I go down 3.5. And then draw the circle. Oh, that one didn't come out so well. Let's try it again. Okay, and then that's it. That's how you would do those. So I'll see you in the next video. Bye.